That was annoying. Okay. Well, I don't know what to do. I have to look into some kind of fix for that, but it's probably gonna take a few hours, so okay. It should be stable now, the stream, I hope. I did quite a temporary fix. Something with my renderer ring buffer or something. I'm not really fully sure on what the problem, but it's breaking and that's why it crashed. Sad. I need to look into it, but I'm gonna do it after the stream, not now, because now we're gonna get this. I don't want to do the other thing. I'm gonna do it tomorrow before going live. Yeah. And also maybe some BIOS update apparently. I'm not really sure what's the problem, but I will do some deeper research on it. Like not during the stream, but after the stream, because it may require a lot of reboots to actually figure out how to fix it and update BIOS. So we're gonna pray that everything is fine and we won't run into any ring buffer issues again. I hope. And yeah, let's see. I hope. There we are. Okay. Educators create interactive, or somewhere here, Educator creates interactive animated 3D models of human body. Many of these applications run directly in the web browser, which is possible because all modern browsers supports efficient rendering with WebGL. So yo. And then demand for 3D content in various applications constantly increased. In many cases, the 3D content has to be transferred over the web and it has to be rendered efficiently on a client. But until now, there has been a gap between the 3D content creation and the efficient rendering for 3D content in runtime applications. How many minutes did we just lose because of that stupid problem? It's pissing me off, to be honest. But I'm gonna do it after stream, fix it. Maybe when I wake up or before going to bed, but yeah. Also, I'm gonna do a full system reset, I don't know. Well, it's the second time it happens, so I should probably look into it. But I'm gonna do a full system reset the 21st or so, I think. Oh, right, it may happen also probably later than that. 25th. Depending on what happens. Let's see. 3D content pipelines. 3D content that is rendered in client applications comes from different sources and it's stored in different file formats. The list of 3D graphics file formats on Wikipedia shows an overwhelming number with more than 70 different file formats for 3D data, serving different purposes and application cases. For example, raw 3D data may be obtained with 3D scanners. These scanners usually provide a geometry data of a single object, which is stored in object ply or STL files. These file formats do not contain information about the scene structure or how the objects should be rendered. More sophisticated 3D scenes can be created with authoring tools. These tools allow one to edit the structure of the scene, the light setup, cameras, animations, and of course the 3D geometry of the object that appears in the scene. Applications store this information in their own... Wait, what? Custom file formats, for example, Blender stores the scene in .blend files, lightweight 3D uses LWS file format, 3D Max uses Max file format, and Maya uses Ma files. In order to render such a 3D content, the runtime application must be able to read different input file formats. The scene structure has to be parsed and the 3D geometry data has to be converted into file formats required by the graphics API. 3D data has to be transferred to graphics card memory and then the rendering process can describe which sequence of graphics API calls. Thus, each runtime application has to create importers, loaders, or converters for all file formats that will support, as shown in image 1b. Well, yeah, that's nothing, yeah, good. GLTF transmission format for 3D scenes. The goal of GLTF is to define a standard for representing 3D content in a form that is suitable for use in runtime application. The existing file formats are not appropriate for this use case. Some do not contain any scene information, but only geometry data. Others have been designed for exchanging data between authoring application, and their main goal is to retain as much information about the 3D scene as possible, resulting in files that are usually large, complex, and hard to parse. Additionally, geometry data may have to be pre-processed so that it can be rendered with the client application. None of the existing file formats were designed for use case of efficiently transferring 3D scenes over the web and rendering them as efficiently as possible, but GLTF is not yet another file format. It's a different definition of a transmission format for 3D scenes. Let's quickly take a look on... Yes. The scene structure is described with JSON, which is very compact and can easily be parsed. The 3D data of objects are stored JSON? Compact? Is it? It's literally just a text format, basically. Like taking the same amount. I don't know. But isn't it? Like, is it actually compact? The 3D data of the objects are stored in a form that can be directly used by the common graphics API, so there is no overhead for decoding or pre-processing the 3D data. Different content creation tools may now provide 3D content in the GLTF format. An increasing number of client applications are able to consume and render GLTF. Some of these applications are shown in image A, so GLTF may help to bridge the gap between content creation and rendering, as shown in image 1C. Increasing number of content creation tools provide GLTF import and exporting directly. For example, the Blender manual documents how to import and export PBR materials using... Alternatively, other file formats can be used to create GLTF assets using one of the open source conversions of utilities listed in GLTF Project Explorer. The output converts and exports can be validated using... that's great. Okay, so we got one down. Basic stuff about that, but okay. The basic structure of GLTF. The core of GLTF is JSON. The file describes the whole content of the 3D scene. It consists of a description of the scene structure itself, which is given by a hierarchy of nodes. Okay, so they use the node graph. What kind of makes sense, I guess. That define a scene graph. Yeah. Node graph, scene graph. The 3D objects that appear in the scene are defined using meshes that are attached to the nodes. Materials define the appearance of the object. Animations describe how the 3D objects are transformed, rotated or translated over time, and skins define how the geometry of the object is deformed based on skeleton pose. Canvas graph on the view configuration for the renderer. The JSON structure. Scene objects are stored in arrays in JSON file. They can be accessed using index of the respective object in an array. Meshes. Why do they have meshes when I talk about scene? Which are these? Meshes then stored in arrays inside of the scene, or are all of the meshes in an array outside of the scene? Well, whatever. These indices are also used to define the relationship between objects. The example above defines multiple meshes, and a node may refer to one of these meshes using the mesh index to indicate that the mesh should be attached to this node. Yes, a node, and then you just index which mesh. The following image, adapted from the GLTF concept section, gives an overview of the top-level elements of the JSON part of GLTF assets. Scene. A node can refer to a node, and then skin, accessories, animations, yes. Camera, mesh, material, texture, image, sampler, buffer, view, buffer. Okay. These elements are summarized here quickly. To give an overview with links to the respective section of GLTF specifications, more detailed explanation of the relationship between these elements will be given in the following sections. The scene is the entry point for the description of the scene that is stored in GLTF. It refers to the node that defines the scene graph. Okay, the node is one node in the scene graph hierarchy. It contains a transformation, a rotation of or translation, and it may refer to further child nodes. Additionally, it may refer to mesh or camera instance that are attached to the node, or to a skin that describes a mesh deformation. Okay, so it's then... So you have a scene, then you have nodes in scene that can have child nodes, and these are just... Yeah, different meshes that can be attached to different nodes. It's a bit weird. I'm still trying to piece together how it's going to work with the animations, but we'll find out. The camera defines the view configuration for rendering the scene. We will probably never care about that. Hopefully not. A mesh describes a geometric object that appears in the scene. Well, actually, it would be kind of cool to care about the camera, wouldn't it? But I can't really see here a case for it. A mesh describes a geometric object that appears in the scene. It refers to accessors, objects that are used for accessing the actual geometric data, and the material that defines the appearance of the object when it's rendered. So just the skin defines parameters that are required for vertex skinning, which allows the deformation of a mesh based on the pose of a virtual character. The values of these parameters are obtained from an accessor. Okay, an animation describes how transformation of a certain node, rotation, translation change over time. The accessor is used as an abstract source of arbitrary data. It's used by the mesh skin and animation. So the mesh skin and animation. Okay, so that means just the animation is kind of like what I did for the meshes earlier, but now a bit more. Provides the geometric data, skinning parameters, and the time-dependent animation values. Oh, time-dependent. Okay, I was thinking like how do we work through, but okay, now maybe let's see. It refers to the buffer view. Okay, I'm not sure about the buffer view, which is a part of the buffer that contains the actual raw binary data. The material contains the parameters that define the appearance of an object. Usually it refers to texture object that will apply to render geometry. The texture is defined by a sampler. Texture is defined by a sampler. Texture is refined by a sampler. Okay. And an image. Okay. Okay. So that becomes a texture one. Sampler and image. That makes sense. Sampler defines how the texture image should be placed on the object. Reference to external data. The binary data like geometry and textures of the 3D object are usually not contained in JSON file. Instead, they are stored in dedicated files, and JSON part only contains links to these files. This allows the binary data to be stored in form that is very compact and efficient, and can efficiently be transformed over the web. Additionally, that the data can be stored in format that can be used without having to parse, decode, or pre-process the data. Okay, so GLTF JSON file, scene, nodes, camera, animation. JSON part describes the general scene, structure, and elements like camera and animations, and it contains the link to files with binary data and images. Buffers. Buffers URI buffer 0.bin, byte length, pretty big. Just 102 kilobytes. Binary files, raw data for geometry, animation, and skins, so this is just where to find it. Okay, images, URI image, that's okay, so this, okay. Okay, JPEG, PNG files, image for the textures, the models. As shown in the image above, there are two types of objects that may contain such links to external resources, namely buffers and images. These objects will later be explained in more detail. Reading and managing external data. During processing GLTF assets starts with parsing JSON structure. After the structure has been parsed, the buffer and the image objects are available in top-level buffer and image arrays. Respectively, each of these objects reading and managing external. Reading and processing GLTF starts with the parsing of the JSON structure. After the structure has been parsed, the buffer and the image objects are available in top-level buffer and image arrays. Okay, respectively, each of these objects may refer to blocks of binary data. For further processing, this data is read into memory. Read to memory. Usually, the data will be stored in an array so that they may be looked up using the same index that is used for referring to the buffer image object that they belong to. I don't understand, my music just dies every now and then. Pretty funny. Okay. Binary data in buffers. A buffer contains a URI that points to the file containing the raw binary buffer data. This binary data is just a raw block of memory that is read from the URI of the buffer with no inherent meaning or structure. The buffer view and access section will show how this raw data is extended with information about the data types and the data layout. With this information, one part of the data may, for example, be interpreted as animation data, okay, and another part may be interpreted as geometric data. Okay. Storing the data in binary forms allows it to be transferred over the web much more efficiently than in the JSON. Why the hell does the music die all the fucking time? I really need to do a full system wipe. I don't know, my system is starting to die here. I have quite bloated it because it's kind of soon continue reading. I just well, I haven't really restarted my Arch Linux since I first got it, which is almost like a year ago, and did I have any idea what I was doing when I got it. I have files in places where I shouldn't have binary files or something like that. Things are a bit messed up in my system right now. But I'm planning to do this month I'm gonna do a full restart. I may do a live stream on it on my laptop. And you guys can see me just painfully trying to fully wipe my whole system and reinstall it. It's gonna be great. It's gonna be great. Yeah. Stay tuned for that. Anyways. And then make it to a video. That will be awful. That will be fun. Storing it in binary form allows it to be transferred over the web much more efficiently than in the JSON format, and the binary data can be passed directly to the renderer without having to decode or pre-process it. That's, yeah. Image data in images. an image may refer to an external image file that can be used as texture of a rendered object. Why did it need to do that though? For two reasons right now that is quite apparent is that randomly my computer just dies. I think it's just because I haven't updated my, I don't know, understand Linux more or something corrupted. It's a bit of both actually, yeah. I think I have something corrupted. Also memory. I have partitions scattered on my system because I had dual boot for a while. So I have 1.6 terabytes dedicated to Windows, and I haven't launched Windows in the past 7 months or so. So I will completely just nuke it from the computer as well and get that memory, or not memory, disk space back and use it for Linux dedicated. But yeah, like I have like 3 partitions right now for Linux because Windows fucked me slightly, and then I boot into Windows once and it fucked my bootloader, so I had to I don't know, man, it wasn't fun. I'm never starting Windows again on this computer, so that's why I'm also nuking it completely, eradicating it. Fuck Windows, man, so fucking bad. It's literally a joke, that operating system, I swear to God. Okay, I'm a bit extremist right now, but you guys get me, right? Even though this one is right now crashing, but the reason why my system is crashing now is not because of Linux, it is because of me doing bad decisions, alright? So I can at least take it then, you know, but when Windows does a blue screen, that's not because you are dumb, it's because the fucking operating system is dumb, and that's just awful, and you can't even take responsibility for that. Like, you're just there like, okay, I guess. like you're fuck. Yeah, I haven't switched to Windows for a long time, but sometime I need Office for my schoolwork. Yeah, my boot is working all fine though, yeah. I use virtual machine if I ever need to go into Windows. This one is fine. If I ever need to launch Windows, I go through a virtual machine. Because usually what I want to do on Windows is not like, it's not gaming. Even though I don't know how bad it would be, because you could do pass-through for your graphics card. So I think, I haven't tried it, how bad it would be. But any kind of like music or text editing or anything else that I need to do through Windows is usually it's not that heavy. So I can just launch a virtual machine for Windows and just do it there, and that's enough. I can deal with that, just barely scraping it, and that won't fuck up my bootloader. Let's see, where was I? Yeah, binary data in binary data in data URI. Usually the URIs that are contained in the buffer. Usually the URIs are contained in the buffer and image objects. We point to a file that contains actual data. As an alternative, the data may be embedded into a JSON in a binary format by using data URI. Wait, what the fuck? As an alternative, the data may be embedded into a JSON, in a binary format. Okay, now I've understood. Okay. Okay. That's crazy, we're getting there. Mini GLTF file. A minimal, not mini. The following is a minimal but complete GLTF asset containing a single index triangle. You can copy and paste it into a GLTF file, and every GLTF based application should be able to load and render it. This section will explain the basic concept of GLTF based on this example. Virtual machine is a nice idea, I'm just too lazy to set it up. My machine only have 1 terabyte, so get rid of Windows would be great. Yes, maybe sometime in the future. Yeah, like literally just hold on. It's like there's different kind of virtual machines you can use, right? But I found this one has been really great for me to use. don't remember, was it Virtio? Yeah, that was the drivers that I got. Let's see if I can get it. I don't remember what its name was. No, what the fuck am I on about? Hold on, I swear it was called that. Yeah, but here I got the drivers from, but You'll be alright. But I really recommend it because having the dual boot is such... Of course you still need like space for your virtual machine. I don't know, can you like change it afterwards? What I meant to do. Oh wait, open. A little bit of sidetrack that I'm getting again, but that's okay. Well, I guess you could just add more disk space. But yeah, just give it 128 gigs from my system. I guess you could just... you could probably just add here, add hardware, and you could go, let's see... Yeah, storage. And you could just add more storage if you ever need it. But yeah. Now I practice music every morning for a half an hour or so. And the application I'm using FL Studio for the actual music, but for also practicing I use a different application which only exists on Mac OS and Windows. So yeah, need that damn Windows. Anyways, we're gonna look at this basic triangle here with scene 0. And then here's all of the scenes. Freaking crazy. With all of the nodes. And in this node it says that we want to access in the index 0 node. The nodes... Well, this is the only node. And it says to access mesh 0. And in meshes we only have this one which has this primitives, attribute, position and indices. And then primitives, attributes. Wait, what the fuck? How do I... Positions, how the fuck am I supposed to... I assume it's something like this, right? I want to get access to this one. Thanks for the recommendation, but wait, you make your own music? Yeah. Not anything good, really. Like, I'm just... No, editing videos, I actually use DaVinci Resolve on Linux. So I do all of my video editing on DaVinci Resolve. Every video I make is on... Well, everyone since I got Linux is through here, wait. Let me see... There. So, wait, where did I get Linux? It's here, I think. This one is still in Windows. Yeah, but here I have been using Linux since this. So all of these videos are purely edited in Linux. I haven't used any Windows for any of these videos over here. And same for the live streams, have also been only in Linux. Well, apart from... I need to get rid of his live stream brother. But if we go a bit down, I did a part here. These music videos, they are actually on Linux, but it's through the virtual machine. This is where I started to do a bit of music. But yeah. Let's see. I still want to figure out, because I understand that it's somehow getting the accessors, but where is it understanding to use the accessor? Because it goes to the mesh. Mesh understands. I understand this. Okay, but there is indices 0, so I guess position 1. That I don't understand. Attributes. Somehow it's supposed to understand to get this, because the accessor then has the buffer view, the buffer offset, byte offset. I mean, count 3 scalar. Yeah. We'll see, they probably explain it here. The scene and node structures. Or structure. The scenes array is the entry point for the description. Wait, the scenes array is the entry point for description. What? Let me just actually do this so we can see it side by side. So the scenes is the entry point for the description of the scenes that are stored in GLTF when parsing a GLTF JSON file. The traversal of the scene structure will start here. Each scene contains an array called nodes, which contains the indices of node objects. These nodes are the root node of scene graph hierarchy. Okay, so you can have multiple root nodes in a scene. That's crazy. For example, here consists of a single scene. The scene property indicates that these scenes is the default scene that should be displayed when the asset is loaded. The scene refers to the only node in the example, which is the node with the index 0. Oh wait, they actually have the same thing over here, bruh. This node in turn refers to the only mesh which has the index 0. More detail about scenes and nodes and their properties will be given in the scene and nodes section. Okay, we'll get more about it later on, right? The meshes. A mesh represents an actual geometric object that appears in the scene. The mesh itself usually does not have any properties but only contains an array of mesh primitive... Okay, wait. Primitive, it's here. Which serves as building blocks for larger models. Each mesh primitive contains a description of geometric data that the mesh consists of. For example, consists of a single mesh and has a single mesh primitive object. In the example, not for example. Sorry guys, it's just this accident that is taking over right now. Okay. The mesh primitive has an array of attributes. These are the attributes of the vertices. The mesh primitive has an array of attributes. Yeah, that makes sense. These are the attributes of the vertices of the mesh geometry, and in this case, this is only the position attribute, describing the position of the vertices. The mesh primitive describes an index geometry. The mesh primitive describes an index geometry. This one. Which is indicated by the indices property. By default, it's assumed to describe a set of triangles, so the 3 consecutive indices are the indices of the vertices of one triangle. The actual geometry data of the mesh primitive is given by the attribute and the indices. These both refer to accessor objects, which will be explained below. A more detailed description of primitive can be found in meshes section. Yes. The buffer view and accessor concepts. The buffer view and accessors. Objects provide information about the geometry data that the mesh primitive consists of. They are introduced here quickly based on the specific example. A more detailed description of this concept will be given in the buffer view and accessor section. Then, a buffer defines a block of raw, unstructured data with no inherent meaning. It contains an URI which can either point to an external file that contains the data, or it can be a data URI that encodes the binary data directly in the JSON file. In the example file, the second approach is used. There is a single buffer containing a 44 byte. The data of this buffer is encoded as data URI. Okay. Octet stream base 64. Okay, that's crazy. Byte length 44. This data contains the indices of the triangle. Ah, okay. Ow. The indices and the indices of the triangle. Wait, this contains the indices. Not the triangles. Okay. Or the triangle, the vertices. And the vertex position of a... Okay, wait, it was a... And the vertex, so it's both. But in order to actually use this data as a geometric data of a mesh primitive, additional information about the structure of this data is required. This information about the structure is encoded in the buffer view and the accessor object. Okay, I see. A buffer view describes a chunk or slice of the whole raw buffer data. In the given example, there are two buffer views. They both refer to the same buffer. The first buffer view refers to the part of the buffer that contains the data of the indices. That's the byte offset 0 referring to the whole buffer data, and a byte length of 6. The second buffer view refers to the part of the buffer. Wait, what? The second buffer. Okay. Refers to the part of the buffer that contains the vertex position. It starts at buffer offset 8 and has a byte length of 36 that is extends to the end of the whole buffer. Why is there 2 bytes in between them? What is this target anyways? Accessors. The second step of structuring the data is accomplished with the accessor object. They define how the data of the buffer view has to be interpreted by providing information about the data type and the layout. How the data of the buffer view has to be interpreted by providing information about the data type and layout. Okay. In the example, there are 2 accessor objects. The first accessor describes the indices of the geometric data. It refers to the buffer view with index 0, which is the part of the buffer that contains the raw data for the indices. Additionally, it specifies the count and type of the elements and their component type. In this case, there are 3 scalar elements, and their component type is given by constant that stands for this unsigned short type. Okay, now I understand why, because I didn't fully understand when I did this implementation. Because there were different types, yeah. These types, I didn't understand. I was like, what the fuck? Why are there so many types here? I just did it because the tutorial told me to implement different kind of conversions for these things. I didn't fully understand, but now it makes sense. The second accessor describes the vertex position. It contains a reference to the relevant part of the buffer data via the buffer view with index 1 and its count type. Count type and component type. Component type? Oh, that's crazy. Properties say that there are 3 elements of 3D vectors, each having float component. So they say that there are 3 elements of 3D. Okay. But how does it know it's a count is 3, the type is vector, and type is this saying that it's a float? As described above, a mesh primitive may now refer to these accessors using their indices. Primitive attributes position 1, indices 0. Okay, when the mesh primitive has to be rendered, the renderer can resolve the underlying buffer view and will send the required part of the buffer to the renderer, together with the information about the data types and the layout. A more detailed description of how the accessor data is obtained and processed by the renderer is given in the buffer view. Yes. The asset description. In GLTF 1.0, this property is still optional, but in subsequent GLTF version, the JSON file is required to contain an asset property that contains the version number. The example here says that the asset compiles to GLTF version 2.0. Okay. Okay. Good. Then scene nodes. Gonna be right back. I'm gonna grab a little something. Gonna put this one on idle real quick. Okay, I'm back. Grabbed a little bit of a... I don't know what they're called. Xylitol? And scene and nodes. Oh, this is gonna be hard to talk now. Great. Since there may be multiple scenes stored in one GLTF file, the scenes property indicates which of these scenes should be the default scene that is displayed when the asset is loaded. Each scene contains an array of nodes, which are the indices of the root nodes of the scene graph. Again, there may be multiple root nodes forming in different hierarchies, but in many cases the scene will have a single root node. The most simple possible scene described has already been shown in the previous section, consists of a single scene with a single node. Nodes for forming the scene graph. Each node can contain an array called children that contains the indices of its child nodes. So each node is one element of a hierarchy of nodes, and together they define the structure of the scene as scene graph. Actually, this also reminds me a little bit. This is a UI library written in short C layout in C. And I wonder, do they use, like, how do they use, because I'm thinking, like, if you do a UI library, wouldn't be using a C node then, or some kind of, like, node graph or something like that too. Let's see. They don't mention nodes, but that's also just the initial. I wonder how dynamic it is. Anyways, we're gonna be doing UI rendering as well, so it's just something I got to think about here while I was reading this thing. I was like, but we're gonna get to that. For now, we're still just focusing on loading models and animating. Gonna do animations. And then after that, I hope it will be UI. But we'll see. Okay. Did I read this part? I read this part. No, yes. Scene graph. Okay, I should probably look for graph. No graph? Oh. Graphics. No, that's it. Uh-huh. Okay. Image A, the scene graph represents stored in the GLD of JSON. Mm-hmm. Each of the nodes that are given in... Wait, so... I wonder, when you export in Blender, does it know to do this for you if you export in the GLTF format, or will it still export the wheels as two separate meshes? Don't know. Not really my priority to figure out right now, but if someone would know, that would be cool to know. Each of the nodes that are given in the scene can be traversed recursively, visiting all their children to process all elements that are attached to the nodes. The simplified pseudocode for this traversal may look like the following. In practice, some additional information will be required for the traversal. The processing of some elements that are attached to the node will require information about which node they are attached to. Additionally, information about the transform of the nodes has to be accumulated during the traversal. But does it? Isn't that kind of like baked into it? I don't know. Local and global transform. Each node can have a transform. Such transforms will define a translation, rotation, and or scale. This transform will be applied to all elements attached to the node itself. What? Hello, Kayal. To the node itself, and so it's all its child nodes. The hierarchy of node thus allows one to structure the translations, rotation, and scalings that are applied to the scene elements. It's going alright. Streams crashed once, music stopped died once, twice. So I'm gonna do a full system reset eventually. Nah, this month we're gonna do a full system wipe. I'm gonna nuke my whole computer and reinstall Arch Linux. I'm sticking with Arch Linux. I'm not switching. I could go for Gentoo, but the thing is to compile everything from source all the time. Like, I would love to do it, but my I would need a faster computer, man. And going to something more stable is not what I would want to do, because I really like Arch. It's my home turf, you know what I'm saying? I like it. Maybe someday if I really get tired of fucking up, but I don't think I will. Maybe. Yeah. Arch is the beast, it's the best. Well, depending on who you are. I mean, I could totally see myself also one day just not wanting anymore, but right now I'm very hyped about it and like it. Except for the times when... But there's always workarounds, you know? There's always workarounds. You can always make something work in a scuffed way, and that's when your system just crashes randomly sometimes. But that's because you just didn't... I just don't... Yeah, you need to figure out a little bit more, but eventually you'll get there. Local transformed nodes. It is useful. Yes. No any AI shit. Well, that's the weird thing, you know. Most people, I kind of use it just because I enjoy it. I don't mind the AI stuff, to be honest, but yeah, I really don't mind the AI stuff. But I just find that Arch is so nice. Like I get to do, like I have full control of the system, and if it crashes, then it's my fault, you know. So then I need to figure out how to fix it. That's what I like about it. I don't mind if it was AI in it, but I mind it when I do not control it anymore. That's when I don't like it. There are different possible representations for local transform of node. The transform can be given directly by the matrix property of the node. This is an array of 16 floating point numbers that describe the matrix in column major order. For example, right, is that's when you go right? The following matrix describes a scaling about 2, 1, 0, 5, a rotation about 30 degrees around the x-axis, and a translation about 10, 20, 30. Yeah, X, Y, Z, column major. And then the scaling is on the... What the fuck? Isn't the scaling on the diagonal? But I don't see... maybe I got it wrong. I mean, putting it in an OS. Making more error-free OS. Yeah, okay, yeah. My friend used Visual Studio today, and apparently you need a Copilot subscription in order to get the, was it LSP for C++ or something like that. I was like, what the fuck? What? That's just fucked up. Maybe I misread it, but I remember it wrong. But something like that, and that's just dumb, you know. I like it because it can do the thing I don't want to do, like shader and sadly optimization. You mean AI or the operating system? Yeah, I mean, with the AI thing, I think, well, Windows is targeting more users who don't want to install stuff on their system. Like, if I wanted an AI, I can get an AI on my system. Like, the closest thing I do get to that is just going... I do have the Claude, like this. And then I just run that through the terminal and ask for things, but it does not have... Well, I guess it pretty much could have full access to my system. But you know, you can customize and do whatever you want if you want some specific AI to run on your system, right? For researching AI is the best and more convenient than... Yeah. It is. My friend told me, or in a group chat, that AI is kind of like more like breadth first search, and the humans are more like depth first search, you know, BFS and DFS. Depth first, the DFS, yeah. So like AI it's pretty broad and fast at finding like a lot of answers and combining and connecting, but it doesn't understand the depth. That's where we humans, we are very slow, you know, at finding everything. But then again, we know kind of we can go deep into things and figure out how do things actually connect on a low level. And that's actually, I think that's pretty accurate in a lot of ways. Like it is, it's good, you know, on the surface level. It can do a lot of cool things and connect things, and you can go do cool stuff with it. But then when it actually comes to doing something sophisticated, it's, well, I don't know, I've heard stories, but I haven't seen it myself yet, where it's actually doing something really Yeah, maybe I don't know enough, you know. I don't know enough, probably. The coding, do not bother yourself. You will not learn and improve. I don't know. I find like with AI, I can also learn. Like when I do have a bug that I cannot figure out, where you could be spending like probably 10 hours and just tweaking the wrong lines of code. AI is pretty fast to just help you and figure out what the problem was. Or sometimes I just have the most absurd, like I have a typo somewhere, but I'm searching in the wrong file for something else, and then it's like, oh, but you wrote the texture file wrong, so it loaded some other file, and I was like, ah, yeah, that makes sense. And I thought the colors were inverted or something like that. So then I find it like it's quite useful. Hello, Dune Bertel. How's it going? It's going pretty good. We are learning a little bit more about GLTF loading. I had done it once, but I really didn't fully comprehend what I was doing. I was just following a tutorial, and it was a C++ tutorial, so I struggled to. I focused more on translating object-oriented design to data-oriented, rather than focusing on the GLTF loading. So yeah. Personally, I use AI, but I told it that do not write any code. Yeah. I don't know. It's kind of weird because if I tell it to not write any code and then it gives a suggestion of some code and I'm like, it already gave a suggestion, what's the difference from me copy pasting it? That's the same as copy pasting from, what is it called? Oh my god. Stack Overflow. How did I forget the name of that? You know, before AI existed, I also copy pasted code from Stack Overflow, and before I ran it, I tried to understand what it did, but I would still like, I would use it as its Stack Overflow. You know, what's the difference for you to Google something, going to Stack Overflow, copy pasting, and then or just ask AI and do the same thing? You know, it's just, do you take the time to understand it or not? And sometimes I don't. Sometimes I just take the code straight from there and just go like, lol, it works. I don't really care about this section right now or anything like that. I have used it also for generating a capsule, because I really didn't care about how do I generate a 3D capsule vertices and all of these. I just wanted a capsule, and then it just did it. I was like, well, it looks right. It's probably is right. I didn't care about going more in depth because the rendered a capsule. I was like, that's probably good. It renders a capsule, and it's such a small piece of the whole thing. It didn't render. I told it how to do the vertices, generate the vertices of a capsule, which probably would have been the same as me trying to Google it, but and then copy pasting it. It only teaches me concepts. Yeah, concepts. Those are really good. Hey. Okay. It's getting a bit dark, isn't it? I wonder if I should put some... Nah, we are gonna continue on like this. The transform of the node can also be given using translation, rotation, and scale properties of a node, which is something sometimes abbreviated as RTS. TRS. Translation, rotation, scale. TRS. I want to make an RTS game, so that's why I wrote it RTS. But this is not the. I'm not making an RTS game, but I wanna so badly wanna make an RTS game. I'm gonna get there. Now, first I need to make a game that is multiplayer to understand how anything of this works, and after that I can go to an RTS, because there you will have to optimize a lot if you're gonna be having thousands of units walking around, right? Right now that's not my priority. I don't wanna be too much considerable about should I render this entity or not. I just wanna be able to do the multiplayer game and that whatnot, and the rendering and these things, but not about too much optimizations. But we're gonna get to that later. One thing at a time, right? Let's see. So there you just give the translation and rotation and the scale. Pretty basic stuff. They do the rotation probably using quaternions because there are 4 components there, or rotors. Each of these properties can be used to create a matrix, and the product of these matrices then is the local transform of the node. The product of these matrices. Ah, okay. But nowadays it acts like dumb, I don't know why. Yeah, it actually has gotten worse, I feel. In the past it was great. Yeah, I feel like it was better in the past. Well, depending on a lot of things, but I think it's like it can do broader things nowadays, but I feel like it does some silly mistakes out of nowhere, like it gets a stroke or something. The translation just contains the translation x, y, z, for example. From translation of one can create a translation matrix that contains this translation as its last column, as shown in figure. But isn't that now row major matrix? Because the previous wasn't... Wait, hold on, am I dumb? Yeah, this one is column major. What did I put it? Am I huh? Well, I guess it doesn't really matter which order you put them in for the... Well, it's not even the same matrix, is it? No, wait, this is flipped, yeah, so they switched it to row major, right? I think. Because this one was row major. No, column major. Now isn't this row major? I have paid one even. Yeah, I'm paying right now for Claude. Because I think Claude is like so superior to... Like I use it for also school, practicing to exam. I kind of have it like, I have given it previous exam examples or code exercise, not code exercises, economic exercises. And then I just have it to generate me new ones based on those ones, and I try to figure out what things are, and yeah. I feel like it's pretty good, because then I can just review my answer and say that you did great, but here's a small problem with this thing, and then I clarify what I meant or something like that. Or write a description of what a word means or something like that. Definition. Does not understand what I want. Yeah, will you be using the library? Yeah, well I got to go. Yeah, Doom Workdale, I will be using the library. Mine is Claude Pro. Yeah, Claude Pro. I'll probably pay for the full year, because right now I'm paying monthly basis, but I don't know, if there comes out another model, you know, you want to be able to quite easily just switch to another. Welcome back, Penguin Operator. The rotation is given as a quaternion, okay. The mathematical background of a quaternion is beyond the scope of this tutorial. For now, the most important information is that the quaternion is a compact representation of a rotation about an arbitrary angle and then around an arbitrary axis. It is stored as a tuple, x, y, z, w, where w component is the cosine of half of the rotation angle. For example, the quaternion describes the rotation about 30 degrees around the x-axis. So this quaternion can be converted into a matrix as shown in image 4D. I don't really understand like how the quaternions goes into a matrix. I don't know, maybe I shouldn't really care, because that's a lot more the math side. Wait, cosine. I just want to see this one thing. 0.9966. Ah, wait, I have the wrong units. No, I don't. I don't know, man. You paid yearly. That's probably good for better for your money. I have only used it for 2 months or so now. So, yeah. The scale contains the scaling factor. Oh wait, hold on. Yeah, the x, y, z axis corresponding matrix can be created by using these scaling factors as the entries on the diagonal of the matrix. For example, the scale matrix for the scaling factor 2105 is shown in figure. This is what I find so weird. Somehow, the rotation and the scaling can share these two places. That's friggin' weird, man. To compute a final local transform matrix of the node, these matrices are multiplied together. It is important to perform the multiplication of these matrices in the right order. The local transform matrix always has to be computed as M transform TRS, transform rotation scale, transform rotation scale, where T is the matrix for the translation part, R is the matrix for the rotation part, and S is for the scale. So the pseudo for the computation is create translation node, create rotation node, and then isn't it the other way around? Don't you scale first, then you rotate, and then you move? Because if you move first and then you scale, won't it be like stretched, and then you rotate, then you're rotating along the axis? Wait, okay. Yeah, okay. Yeah, so they move, rotate, and then scale. I feel like that's... Maybe I'm reading it in the wrong order when it actually comes to computational. For example, the matrix is given above the final local transform matrix. The node will be as shown in image F4F. Now that's crazy. The matrix will cause the vertices of the mesh to be scaled, then rotated, and then translated according to the scale, rotation, and translation properties that have been given in the node. When any of these three properties is not given, the identity matrix will be used. Similarly, when a node contains neither a matrix property nor a TRS properties, then its local transform will be the identity matrix. Global transform nodes. Regardless of the representation in the JSON file, the local transformation of a node can be stored as a 4x4 matrix. The global transformation of a node is given by the product of all local transforms on the path from the root to the respective node. What? Regardless of the representation in the JSON file, the local transform of a node can be stored as a... The global transform of a node is given by the product of all local transformations on the path from the root to the respective node. Okay, it's important to point out that after the file was loaded, these global transforms cannot be computed on... Wait, what? It's important to point out that after the file was loaded, these global transforms cannot be computed only once. Later it will be shown how animations may modify the local transform of individual nodes, and this modification will affect the global transform of all these descendant nodes. Therefore, when the global transform of a node is required, has to be computed directly from the current local transform of all nodes. Alternatively, and as a potential performance improvement, an implementation could cache the global transform, detect changes in local transformations of ancestor nodes, and update the global transform only when necessary. The different implementation options for this will depend on the programming language and the requirements for the client application, and thus are beyond the scope of this tutorial. Write code to teach you. Yeah, and then I look at the resource you are reading for confirmation. Yeah, I also do that. I use Claude kind of like first introduction kind of to understand stuff or something, and then I use real sources for confirmation. Hmm. Yeah, buffer views accessors. This is gonna... it's not gonna take too long. Buffer views and accessors. Example of buffer. I do like that. Yes. Very helpful. Yes, it is. No, it's honestly like so good. I really need to get there's you can use Claude or well not Claude sure, but AI tools for different kinds of automation tasks that are just like if you already know how to do something, like then you could just use an AI to just do the repetitive work for you and get those things done. But when it comes to more problem solving or learning, of course, then you should not use it because then you destroy the whole point of doing it. And I take notes. You take notes? I don't take notes anymore because I have never gone like, oh, I should have taken notes and looked this thing up again. Because I never like get that, go back and look at my notes. If I ever needed to look at some notes, I have just been like, what was the original resource? And I went back and read the original resource. So I saved the original resource, maybe where it was. But notes, I never have gone back to look at my notes. That's just... I guess code examples. So there I go back to look at my old code to see how did I do something, if I had something that I... trying to do something similar or tweak something. Yeah, I guess you could count that as notes, but following a tutorial online or something like even lectures, I don't take notes. Because I never read through those notes. I learn by doing, so if I want to learn what they're talking about in lectures, I usually try to simulate some scenario or find some exercise online about what they're talking about to learn it, because I find it easier to learn stuff when I have to retrieve rather than find in like... I think taking notes is probably good, but for me, I figured that I learn better when I have to do something practical and actually retrieve that memory to put it into use. That's when I learn my best, at my best, yeah. That's also why I like AI, because if it's something really, if it's just practicing what different meaning of words means, I usually just give it the list of words that I want to learn and some definition or whatnot, and then I just tell it to start asking me the words, and I will write in my own wording what this word means. And that's how I retrieve or like remember the information. If I just like, I don't remember this word, it gives the definition of the word back to me, and then I'm like, okay, try to remember what it means or try to like ask about the word or whatnot. You write on the device, I mentioned the book and the page. Yeah. I usually, well, it completely, I guess, depends. What kind of books are you reading? Like, yeah. If you're reading books about programming. Yeah. Do you read books about programming? What do you read books about? An example of a buffer view and accessor object was already given in minimal GLTF file section. This section will explain this concept in more detail. Yes. C++ Strauss-Trap. Yeah. I actually had that on my want to read list, but then I was like, in general, then I understand like why you would take notes. Probably, I would say. I just find that when I do anything that is programming related or more, well, like I said, like I prefer learning by retrieval or actually doing the thing. And programming is one of the things where I wouldn't read a book about it, because then I feel like I want to apply it. I don't want to read about it, because you can read so much about programming and never remember what you read. I guess that's why you do the notes, because then you can go back and remember it. But for me, it's like if I'm gonna learn about programming, I want to apply it immediately as I read it, or maybe even try to apply it before I have read about it. Now with this I have actually tried to do this once, so now I'm just reading more about it to connect the more dots and actually put things together. But concepts, programming, if I read about programming, concepts I can read, because that's you can think about concepts, right? But code, when I say programming, I mean specifically like code snippets on how to implement a singleton, for example. And then they show some actual code. I try to remember that doesn't make sense to me. I more or less just try to understand the concept of a singleton would make more sense. And then make the code yourself or something. Or then when you want to implement it, make the code. Or Google it up or something like that. Yeah. I actually have a book in Unreal Engine on how to make games when I wanted to do that. And that's when I realized also, it's actually not my book, it's my friend's book, to be honest. But when I started reading it, I was like, I'm reading a lot about C++ and how to implement something in Unreal. But these pages don't make sense unless if I'm actually like writing the code as I have the book next to me. And I was like, nah. Then I could just be writing the thing instead, without the book. Maybe search online what I explicitly need. I read, take notes, and then apply it. Yeah, everyone has. It's good. I mean, if it works for you, that's great. Let's see, a buffer represents a block of raw binary data without an inherent structure or meaning. This data is referred to by the buffer using its URI. This URI may either point to an external file or be data URI that encodes the binary data directly into the JSON file. The minimal contains an example of a buffer with 44 bytes of data encoding in the data URI. Yeah, okay, so this we have done multiple times already. Parts of the data of a buffer may have to be passed to the renderer as a vertex attributes, or as indices, or data may contain skinning information or animation keyframes. In order to be able to use this data, additional information about the structure and type of this data is required. Yes, always I forget everything, yeah. There's actually like I read mostly books about philosophy or psychology, neuroscience, human behavior, business, also marketing. But these are generally like self development or what they're called. But these are things that you can read and then you can start. Philosophy you can just think about, and it makes you just think, which I like a lot. And then on these other ones, I do read about storytelling as well, which are things I immediately apply to when I do my next video. I try to remember how to write stories, what makes it important, how to, what to speak about, what not to speak about, and also like human behavior is just in general really interesting, especially when you try to do something with business to understand like how do human behaves. Neuroscience is the same, and it's not about applying it. I think I applied more to myself. Like I use myself as kind of like a science experiment in that sense. You can directly immediately apply it onto yourself and see how do you behave based on the knowledge you just read. And then you can quite easily verify if it's true or false what you just read about. And makes you think a lot more again, as philosophy does. Even though I'm reading behavior. But it's kind of, everything is kind of philosophy in a way. So I have actually only read one book about that wasn't non-fiction. I mainly read non-fiction, but I don't know if you count philosophy to science fiction or something like that. I don't think you do. But there was one book that I read about that was that was fiction. And it's honestly well slightly philosophy at the same time, but it was a really good book. Hitchhiker's Guide Through the Galaxy. I don't know. It was so freaking good and hilarious. It's a really good book. Let's see, buffer views. First step of structuring the data from buffer is with buffer views object. A buffer view represents a slice of data of one buffer. This slice is defined using an offset and a length. Oh, this actually makes me understand the slices a little bit better in Zig if they are the same, because I have always been using slices as thinking as they're just raw pointers, just with a size, so you don't have to worry about the null terminator or anything. But maybe you could. Yeah, you don't really need to be the owner. Yeah, as any other raw pointer, you don't need to be the one that was originally allocating it. Yeah. There are too many fancy stuff in Sig that I don't really comprehend. No, it's good, it's good. The slice is defined using an offset and a length in bytes. The minimal GLTF file define two view buffer objects, yes. I am not really sure what this target is still. Will they please tell me what that target is? Are they gonna talk about the target? Yeah, they were gonna talk about the target, good. The first buffer view refers to the first 6 bytes of the buffer data. Yeah? The second one refers to 36 of the buffer data. 36 bytes of the buffer with an offset of 8 bytes shown in the image. So there are 2 dead bytes in between here. The bytes that are shown in the light gray area are padding bytes that are required for properly aligning the axes as described below. Ah, yeah, right, because you only have... Yeah, if you use... if this is 1 byte, you have shorts, basically. You have... Wait, shorts? Yeah. You have 1 byte, 2 bytes, and then you have another 2 and another 2. So these are just for the 3 vertices, right? Or it's actually the indices, this first section. And then you just need for the alignment, you need 2 more. Okay, then it makes sense. Each buffer view additionally contains a target property. This property may later be used by the renderer to classify the type type or nature of the data that the buffer view refers to. The target can be constant indicating that the data is used for the vertex attributes. Hold on, what? Nature of the data that the buffer view refers to. The target can be constant indicating that the data is used for vertex attributes. Okay. Standing for array buffer. Or the data is used for vertex indices standing for element array buffer. Not really sure, but okay, so these are like kind of like identifiers. They're not, that's why they are in numbers. At this point, the buffer data has been divided into multiple parts. At this point, the buffer data has been divided into multiple parts. Each part is described by one buffer view. But in order to really use this data in a render, the additional information about the type and layout of the data is required. Accessors. An accessor object refers to the buffer view. Refers to the buffer view and contains properties that defines the type and layout of the data of the buffer view. Okay, so it just says which buffer view it's talking about, okay. And defines the type and layout of the data of the buffer view. Data types. The type of an accessor data is encoded in the type and the component type. The values of the type property is a string that specifies whether the data elements are scalar, vectors, or matrices. For example, the value may be scalar for scalar values, vector for 3D vectors, or mat4 for forks for matrices. The component type. specifies the type of the components of these data elements. This is a graphics library constant that GL, OpenGL, I think it's a GL constant, that may, for example, be float or unsigned short. What? Yeah, okay, this one is, yeah, okay, that makes sense. To indicate the element have float or unsigned short components respectively. Different combination of these properties may be used to describe arbitrary data. For example, the mini-module contained the two accessors, yes. The vertex refers to the buffer view with index 0, which defines the part of the buffer data that contains the indices, its type, is scalar, and the component type is unsigned short. This means that the indices are stored as scalar unsigned short values, yeah. The second accessor refers to the buffer view with index 1, which defines the part of the buffer data that contains the vertex attributes, particularly the vertex position, its type is vec3, and its component type is float, so its accessor describes a 3D vector with floating point components. But floating would be 4 bytes, right? So 3 times 4 for 1. But then you also have, well, depends. Yeah, 36 bytes. And if you divide that by 4, what do you get? You get 9. Yeah, and then you have 3 yeah, you have 3. Yeah, wait. Yeah. Yeah. And 3 is... Then you divide that by 3, so you have 3 vertices. Yeah. Yeah, makes sense. Okay. Data layout. Additional properties of an accessor further specifies the layout of the data. The count property of an accessor indicates how many data elements it consists of. In the example above, the count has been 3 for the both accessors, standing for the 3 indices and the 3 vertices of the triangles. Respectively, each accessor also has a byte offset property. For the example above, it has been 0 for the both accessor because there was only one accessor for each buffer view. But when multiple accessors refers to the same buffer view, then the byte offset to describe where data of the accessor starts relative to the buffer view that it refers to. What does the max and min then? Data alignment. The data that is referred by the accessor may be sent to the graphics card for rendering, or be used as the host side as an animation or skinning data. Therefore, the data of an accessor has to be aligned based on the type of the data. For example, when the component type of an accessor is float, then the data must be aligned at 4 byte boundary because a single float value consists of 4 bytes. This alignment required of an accessor refers to the buffer view. This alignment requirement of an accessor refers to the buffer view and the underlying buffer. Particularly, the alignment requirements are as follow. Byte offset of an accessor must be divisible by the size of the component type. The sum of the byte offset of an accessor and the byte offset of the buffer view that is referred must be divisible by the size of the component type. In the example above, the byte offset of the buffer view with the index 1, which refers to the vertex attributes, was chosen to be 8 in order to align data of the accessors for the vertex position to 4 bytes boundary. The bytes 6 and 7 of the buffer are thus padding bytes that do not carry relevant data. Image 5c illustrates how the raw data of buffer is structured using buffer view object and is augmented with data type information using accessor objects. Finally, not cubes. Yeah, we're moving away from the cubes. to meshes and level 6, 7. Yeah, we are moving away from the cubes to meshes, and we're gonna get animations. I'm finally gonna understand animations. But if I'm gonna understand animations, I need to understand GLTF a little bit better and how, because I do understand, like, it's something about the bones and the weights, and have to kind of like simulate how they move. Global, local, transforms or translations, and I think I have a very poor understanding about the meshes and the nodes. So that's why I'm reading this, to understand the data more precisely about how they work, so when I get to implementing the actual animations, understand what they're referring to and why these things are happening. Because I can load in this, but I don't know how deep. I don't know it deeply enough to be able to even, well, I don't know. We're gonna see. We're gonna take care of it. We're gonna get there. We somehow managed to get multiplayer working on this project, so I mean, this should be easy, right? For my part. But we're gonna get it done. That's the point that I'm trying to make here. 3 scalars with an unsigned short component and in the indices of the triangle. Yes, that makes sense. Yeah. Data interleaving. The data of the attributes that are stored in the single vertex. How did I get the vertex there? Buffer view may be stored as an array of structures. Yeah. A single buffer view may, for example, contain the data for vertex positions and for vertex normals in an interleaved fashion. In this case, the byte offset of a accessor defined at the start of the first relevant data element for the respective attribute, and the buffer view defines an additional byte stride property. This is the number of bytes between the start of one element of its accessor and the start of the next one. An example of how interleaved position and normal attributes are stored inside buffer view is shown in image 5. But isn't that just the same as how they are stored when doing the descriptor layouts in Vulkan? Because you also have the stride there. Let's see, one buffer view contains position and normals interleaved. Yes, byte stride 24 and byte offset. Yeah. The buffer view defines as byte stride of 24, which is the difference between the start of one accessor element and the start of the next one. And then you have byte offset 12 on the second one, yeah. Okay, finally, but so you can have a stride. I don't know where the stride element comes in, but probably somewhere along here. Data contents. Finally, the min and max. An accessor also contains min and max properties that summarizes the content of their data. There are component-wise minimum and maximum values of all data elements contained in the accessors. In the case of vertex position, the min and max properties thus define the bounding box of an object. This can be useful for prioritizing downloads or for visibility detection in general. This information is also useful for storing and processing quantized data that is dequantized at runtime. But the renderer, but details of this quantization are beyond the scope of this tutorial. Wait. Yes, okay, wait, so you could use those as bounding box? Am I completely crazy for saying that? Sparse accessors. With version 2.0, the concept of sparse accessors was introduced in GLTF. Sparse accessors. This is a special representation of data that allows very compact storage of multiple data blocks that have only a few different entries. For example, when there is a geometry data that contains vertex positions, this geometry data may be used for multiple objects. This may be achieved by referring to the same accessor from both objects. If the vertex position for both objects are mostly the same and differs for only a few vertices, then it's not necessary to store the whole geometry data twice. Instead, it's possible to store the data only once and use a sparse access to store only the vertex position that differs for the second object. The following is a complete GLTF assets in embedded representation that shows example for sparse accessors. That sounds really interesting. I'm not really fully sure what they mean, but let's see. Buffers, buffer view. So buffer view 0, byte of the 0, byte length 72, buffer 0, all access this first buffer 72, 168, 246 length and 248 and 360 accessors. Buffer view, byte offset, component type. Was that the okay? Counter the 6 scalar. Buffer view 1. What? Which? Ah. Yeah, so wait. Yeah, this is the buffer U0, this is buffer U1. Okay, yeah. Offset 0, component type, count, vec3, sparse, count, 3 indices, buffer U2, offset, values. This is so confusing. What the fuck? This is shown in image 5e. The example contains two accessors, one for indices of the mesh and the one for the vertex positions. The accessor one for the indices, yeah, that makes sense, and one for the vertex position, yeah, that also makes sense. But then when you got to this part, I was like, what the fuck happened? The one that refers to the vertex position defines an additional accessor sparse property, which contains the information about the sparse data substitution that should be applied. The sparse object itself defines the count 3 of element that will be affected by the substitution. The sparse indices probably refers to the buffer view that contains the indices of the element which will be replaced. Sparse values. Okay. Refers to the buffer view that contains the actual data. In the example, the original geometry data is stored in the buffer view with the index 1. It describes the rectangular array of vertices. The sparse indices refers to the buffer view with the index 2. The sparse indices with the index 2, which contains the indices 8, 10, 12. The sparse view values refers to the buffer view with index 3, which contains the new vertex position, namely the effect of applying the corresponding substitution shown in image 5. Vertex 8 is at 1, 1, 0. Vertex 10 is at 3, 1. Yeah, okay, that makes sense. The sparse accessor defines substitution for the indices 8, 10, and 12 of the vertex position data. After substitution, the positions are as follow. 8 is at yeah, that makes sense, okay. So it's just different heights. 2. This is 1, 2, 3, 4. Yeah, okay. And that's where we get that. Okay, so wait, so indices we're trying to affect 3 buffer view 2 byte offset 0. And the buffer view 2, that's, hold on. That's this one. And then it takes 6 byte length, yeah, so 2 for, and then we're talking about 3 count, and yeah, okay, then that makes sense. But how does it understand? Okay, and then the values comes from here, buffer u3, and then 0 offset. And that's this last one. So it goes to the last part, and then it gets, yeah, those 3 last vertices and updates the information from there. Okay. Okay. So you could also, in theory, could have the same, another buffer view refer to the same, you could put it repeat itself from like what it was here originally. If you wanted to go like that, you know. That could be pretty crazy. No, that would just be meaning that you could actually move this one to over here if you wanted. But that means you would have to start from 7. And then this one would be moved here, and that one would be moved over here because you go 7, 8, 9. Which would look completely horrendous. But it would work. Well, we're already on animations. Holy shit! This is actual animation, simple animations, simple however animations before this. Anyways, we're gonna get to this thing over here. But yeah, we are here now. Taking some good time to read, but I think it's we're having good discussions here at the same time. We have it cool, we have it nice over here. Simple animation. Shown in the secrets. Shown. Oh damn, it's getting dark. Let me just. Could get the light, but that's more like a studio kind of light thing, so I think it would be a bit too bright. I also don't know how my electrical bill will tank it. I don't really have, if anyone follows me on anything, that it will pop out, so I feel a bit bad about it. Should probably have like the Twitch chat also open on a separate place, just in case for these things, because I cannot see them. Oh wow. Let's see, I'm gonna quickly... Whoa, what am I doing? See if I can just... I used to have a chat separately before as well, but... Let's see if I can... Can I do that? Can I somehow pop out the chat? No, I cannot. What? There used to be a easy pop out. Well, we'll look into it another time. Now we're gonna continue reading. Shown in scenes and nodes section, each node can have a local... By the way, I'm only one watching on YouTube. Thank you for carrying the YouTube. You know, I remember once the day I have 1,000 viewers, I will remember this. When I started, it was just one guy, one person, clapping for me over there, you know? Maybe, we'll see, we'll probably happen. I hope it will happen. One day. Anyways, each node can have a local transform. Yeah. This transform can be given either by the matrix property of the node or by using translation, rotation, scale properties. When the transform is given by the TRS properties, an animation can be used to describe how the translation, rotation, or scale of the node change over time. The following is a minimal GLTF file that was shown previously but extended with an animation. This section will explain the changes and extension that have been made to add this animation. I'm always afraid when the music just dies. So now the node has a rotation over here. And then let's see what else happens. Here are the animations. Samplers, input 2, interpolation, linear output 3, channels, sampler 0, target 0, node, rotation. And then we have 2 buffers now. And the animations, yeah, okay. Sempro, and here I am on Twitch. Awesome. That's so cool of you. I have no overlay or anything like that. I can't see if any special thing happens over at Twitch. I'm the same person. Oh, the same person. The only person with all of my streams. Nah, that's crazy. You can also go on Kick. Yes. Let's see. Buffer views. Accessors, buffer views. Okay. Let's play the animation. Whoa! Like, even doing that simple thing, that would be so freaking cool. I wonder how they do it. Like, I'm still thinking like actual 3D, but how does it work with 2D? Oh my god. Well, it's the same thing, but probably just a bit easier. I don't know if it will be easier because it's like. Well, I guess Eulers works pretty well with 2D because rotating on any other axis than X, Y, Z, depending on which axis you have in towards the camera, doesn't really matter. Because if you rotate like this, then you will lose the thing, and if you rotate like this, you will lose the thing. So just rotating like this, even. Yeah. The rotation property of the node. The only node in the example now has a rotation property. This is an array containing the 4 floating point values of quaternion that describe the rotation. The given value is the quaternion describing a rotation about 0 degrees. Yeah. So the triangle will be shown in its initial orientation. The animation data. 3 elements have been added to the top level array of GLTF JSON. What? And here I'm on Kick. You found me on Kick as well, Sempro. Somebody took your Sempro 551 name? That's fucking crazy, man. I can't be actually tired. Well, yeah, it's towards bedtime for me. No. Speakons have been added to the top level array of the GLTF JSON to encode the animation data. A new buffer containing the raw animation data. Okay, actually I prefer still to have the full thing, even though I know they provide the information, but I would like to see it still here next to the thing. A new buffer. So that was the second buffer that was here. To provide the animation data. A new buffer view that refers to the buffer. And then we had buffer views here, which take off it. And 2 new accessors objects that add structural information to the animation data. Wait, are they the 2 last ones? In what time zone are you? UTC plus 2, I think, or 3. Finland. I think it's UTC +2. Hopefully I'm right. It depends on the season. Winter and summer, they have a switch there. Or is it +1 otherwise? No, UTC +2, I think. It's 21:30 right now for me. So this refers to the second buffer view, yeah, and then the scalar, and then a vec4, okay. The buffer and the buffer view for the raw animation data. A new buffer has been added which contains raw animation data. This buffer also uses data URI to encode the 100 bytes that the animation data consists of. Crazy. Are you from Russia? No, I'm from Finland. There is also a new buffer view, which here is simply refers to the new buffer. With index 1, which contains the whole animation buffer data. Yeah. Further structural information is added with accessor object described below. Wait. Oh, I get it. Yeah. I need to get some divided minds. We don't get that sun, you know what I'm saying? Okay, wait, where was I? I'm getting tired. Now we're gonna read this. And then I need to send some messages, and I need still to do some YouTube work to prepare for the next YouTube video. It's gonna be fire. Or actually, this is preparing for the video after that. But it's okay. Hey, look who's been released from the hospital. Hello. Yeah, I'm alive and doing well. Further structural information is added. Good to see. Yeah. Note that one could also have appended animation data to the existing buffer that wait, what? One could also append animation data to the existing buffer that already contained the geometric data of the triangle, yeah. In this case, the buffer view would have referred to the buffer with index 0 and use an appropriate buffer offset to refer to the part of the buffer that been contained and contained the animation data. In the example that is shown here, the animation data is added as a buffer in the example that is shown here, the animation data is added as a new buffer to keep the geometry data and the animation data separated. The accessor object for the animation data. The two new accessor objects have been added, which describe how to interpret the animation data. The first accessor describes the times of the animation keyframes. There are 5 elements as indicated by the count of 5. Okay, and each one is a scalar float value, which is 20 bytes in total. Yeah. The second accessor says that after the first 20 bytes, there are 5 elements, each being a 4D vector float correspondent components. These are the rotations that correspond to the 5 keyframes of the animation given as quaternions. Yes. Hold on, I have to check. Can I see? If I quickly go, can I see where is? I'm still trying to figure out with my. Can I see it here? No. Now I'm in the right spot. Okay. Okay. Yeah, now I can actually pop out the chat. I should probably put the overlay if somebody ever like follows or something like that, but Yeah, I should. I don't have it right now. I probably should. To get notified. If I do it, I hope... Wait, I think I can just do it, right? Where is it? I think I have it somewhere. Audio overlay. Have I actually removed it? I think I had to because it was... Yeah, okay. We'll take care of it under stream. See, the second exercise says that after the first 20 bytes, there are 5 elements, each being 40 vectors. So 40, so it's 20, so times 4, so 80. These are the rotation that corresponds to the 5 keyframes of the animations given as quaternions. What the fuck did I just say? You have 4 of them, 16 bytes each. So, but how can that, you have 4 bytes, no, 4 bytes per float value, then it's a vector, so you get 16, and then you have 5 of them, which will give you 40, 60. The fuck? Am I doing this completely wrong? Because we have then 20 bytes. I must be doing some math wrong here. Let's see, they probably explain it to me. The actual data that is provided by the time accelerator and the rotation accelerator using the data from the buffer in the example is shown in the table. My brain is melting, don't worry about it, mine is already dead. Time accelerators 0.0, 0.25, 0.5, 0.75, and 1. Rotation accelerators. At 0 seconds, this triangle has a rotation of 0 degrees. 25, it has rotation of 95, 180. So the rotation of 127, which is the same as minus 90 around z-axis. And 1 is 360. So that means there's 2 spots where it just stays still. Nah, it doesn't seem like it. But I guess 1 and 0 is like kind of like 360 degree as well, so they just connect. I hope. So the animation describes a rotation 360 around the z-axis that lasts 1 second. The animation. Finally, this is the part where the actual animation is added. The top level animation array contains a single animation object. It consists of 2 elements. Sampler and channels. Samplers, which describe the source of animation data. Input, okay. The channels, which can be imagined as connecting the source of animation data to a target. Wait, they do not describe more? Okay, wait, before I figure that out, I want to still understand this. Because if you do take 20 bytes out of this 100, and then I don't trust my math right now, okay? If you do take, you have 4, and then a quaternions 4, that will be 16, right? And then you have 5 of them, which is 80. Why did I get 60 in my mind? Right, because 6 times 5 is 30. Not 20. Yeah, that makes sense. When will you do 1080, 7020, etc. peak qualities switch? It's very hard to watch you with my bandwidth. You know I have same time as you and I'm from Russia. I don't think I will ever lower the quality, but can't you just put it on 720? I'm doing 1080 right now. It should be streaming 1080. If it's not, that's a bit concerning. I don't have a monitor that is larger than that. So yeah. We can just manually put it to 720 or something like that. I think it shouldn't be too crazy. But okay, I guess it would be very, very hard to read the texts. I think I would like to get a 4K monitor and stream that. Or at least record in 4K, because making the videos, even though I try to avoid taking footage from the streams, but it would be so much cleaner if I did that. And well, also I do re-record, but I always have to zoom in on the new footage when I'm making a video. It's really annoying if I could just have 4K resolution instead to begin with. I mean, not only 1080 qual, it requires big speed. But yeah, no. But if you want to, I don't know how it, doesn't YouTube, if you want to get streamed on 720, like, doesn't it then just give you like still the bandwidth to get that? Because doesn't it like kind of, I more love Kick. You can watch on Kick, I don't really. Twitch. Yeah, no, that's fine. I don't know, but should Twitch be better than YouTube at that, like giving you option to just get lower quality? And then like, isn't it like kind of sending you first the packets on a like, I don't know, because I'm thinking what I have seen from, I don't know how it works really, but I'm thinking it probably would do something like this, right? If we say this is, we're gonna do this. Actually, I should have done this a bit smarter. We can do it a bit smarter. So if this is the full resolution, right? Let's say this is the almost the full resolution. Now I should have divisible by 2 on both axes.
Yo ho whoa.
Yo, what's up? What's up? But if this is divisible by this is visible. Okay, like this. So shouldn't it first try to like optimize to send you like this this place of the pixels and this, you know, like this, and then once it's thinks that that is good enough, it starts sending you this part of the rendering. Like it has kind of like quadri. I have seen at least when people stream on Discord that they get these larger pixel artifacts. So I'm assuming that they are always like first sending you pixel data.
Lucas, how's it going?
Not
streaming on Discord.
Oh yeah, am I not? Damn. Yeah, okay, yeah, my computer crashed. Let me not start another stream right now on Discord because I don't want it to crash again. It's something with the ring buffer in the with the rendering apparently. I don't know. That was the journal said something like that. But
wait, I will join VIP voice chat because I got to discuss with Cheesecake.
Yeah,
about the project we're doing.
Yeah, do that. I'm almost done with the stream for today.
Good luck. Good luck.
Thank you. Good luck to you too.
Yes, thank you.
I hope the next stream will have this feature. Next stream we will continue reading. We'll just continue. This may take actually, if I continue reading this slow, it will take 2 streams. Maybe I'll try to get this in one go. Next streams to get all of this, and we don't have to stay too long on this. But it's fun. Okay. Let's see. The sampler which describes the source of animation data. Yeah. The channels which can be imagined as connecting a source of animation to data target. Here. In the given example, there is one sampler. Each sample defines an input and an output property. Input and output there. They both refer to accessor objects. Here these are the in time times accessor with the index 2 and a rotation accessor index 3 that has been described above. Additionally, the sampler defines interpolation type, which linear in this example. Yeah, so it just says that I want these two from here. Streams. Yeah, we will. Next streams will have this feature. Yeah. Wait. Oh, wait, what? Oh, you mean this feature in next streams? Oh, I don't know. I thought they would do this because I think Discord does this. At least I have seen like these square artifacts when I have low bandwidth that I get like a lot of these squares when I should be having pixels. I would assume that it sends you like first this high abstract idea of how the image should be looking like, and then it sends you a little bit more detail, and then a little bit more, and then if you don't have time to get these ones, it will just, okay, well, now you're rendering the next frame in this detail. I don't know. Yo, what other languages known and try make 3D render on Scratch? No. Scratch is not my language, man. Maybe, but no. I would, if I didn't do Zig, I would do C. Honestly, that's what I would do. I'm sometimes thinking about doing just C. C is really nice. But so is Zig. There is also one channel in the example. This channel refers to the only sampler with index 0. As the source of the animation data, the target of the animation is encoded in the channel target object. It contains an ID that refers to the... Wait, now I'm losing track of what I'm trying to read. Source. There's a channel in the example. This channel refers to the only sampler with index 0. Wait, let me see now. Channel, sampler... And there should be a sampler somewhere? But... where the fuck is the sampler at? I must be freaking stupid. Oh wait, channel sampler. Is it referring to this? It's. I thought it was something down here. Okay, I'm just tired. Okay, I'm just gonna say it. Okay. What the fuck? It's the source of the animation data. The target of the animation is encoded in the channel target object. Channel target. Okay. Object contains an ID that refers to the node whose property should be animated. The actual node property is named in the path. So the channel target in the given example says that the rotation property of the node with index 0 should be animated. Huh? Ah, okay. So node 0, and then this should be animated. Okay. And then sampler 0, this is what you want to use. And that animation you get, it's a bit weird. I felt like this should maybe have been swapped. Combining all of this information given an animation object says the following. During the animation, the animated values are obtained from the rotation accessor. They are interpolated linearly based on the current simulation time and that the keyframe times that are provided by the times accessors. The interpolated values are then written into the rotation property of the node with an index with the index.
Lucas, go to off topic and read.
Wait, let me just finish this thing. It's like one sentence. A more detailed description and actual example for the interpolation and the computation that are involved here can be found in the animated section. And that's actually the next section that we'll read about. So that's pretty freaking cool. Okay, now I can take a look at, wait, let me see, animations. Simple animation, and we'll have animations next, so 007. Okay, what did you want me to look at?
Lucas, by the way, Cheesecake sent me a little piece of music I want you to listen to.
Wait, was it in Cool Things, or what did you say?
I'll send a thing in, well, looking off topic first. Read from the image where it says black bozo. Read.
Okay. Yeah, I read already, and I'm not gonna read that out on stream.
What? Okay, but then look in VC chat that we're in currently. And,
Yeah.
I sent a video. Cheesecake sent this to me.
I don't know if I dare to press this one on a live stream, bro. I'm just saying.
You can listen to like 2 seconds. It's not copyright.
No, that's not what I'm talking about.
Bro, listen to it.
I-
It's just music.
I think we'll keep it off stream, this thing, bro.
Bro, it is too good. You have to listen to this.
I'm gonna get cancelled
Bro,
immediately.
It's too good.
I don't know. I already heard like the slight beginning there. I don't
No.
know. I don't
Bro, they're
know.
saying Miguel. Alright, they say his name.
I don't know, man. I don't know.
Oh, it's so good. It's too good. It's too good.
I don't know. I hear that.
Bro. Can you like disable the audio on stream so you can listen?
Oh
Because it's so fire.
yeah. It's nobody else. Actually, nobody hears this audio. To be honest.
Okay, good. You can listen to it.
Yeah. Yeah, it doesn't sound like that's what they're saying, but that's great.
No.
That's great.
That is what they say.
All right.
Trust me, bro.
That's fantastic. Anyways, guys,
Oh, it's so good.
tomorrow we'll continue reading this thing.
Derby.
Yeah, and hopefully I will maybe read a bit faster, so we'll actually get through all of these. It's not much to read, quite easy to well, because I already implemented once this, but I didn't ever understand what I was doing. Doesn't seem too complicated. But we'll see. Tomorrow again. And yeah, stay tuned for the next video. It's gonna be freaking fire. Trust me on that one. I haven't updated my profile picture of this. That's maybe what I will do actually now after the stream. Alright, that will be it. Good night, take care everyone, and I will see you tomorrow. Bye bye.
Alright, I'm back. What, Lucas, did you enjoy the Miguel song?
And in the stream, you wanna hit it?
I'm gonna beat it.
What's a piece of shit?